Now, let us come to Huygen's web theory. So, Huygen explained how light waves can travel in a medium. At that time, Huygen assumed that there is a medium called ether which pervades all the universe. It is present in vacuum. So, light is a mechanical wave and it can traverse through all the medium from sun to earth, and inside it can pass through glass, any water, anywhere. So, everywhere this universal ether medium is present, and he was not sure whether the light is a transverse wave or longitudinal wave, but he guessed it to be a mechanical wave which requires a medium called ether medium. Now, let us see what are the salient features of Huygen's wave theory. So, number one point is its theory was based on geometrical constructions according to which if we know the shape and position of the wavefront at a time, then with the help of geometrical constructions we can determine its shape and position at any other instant. So, it was based on geometrical constructions. Second point, Huygen assumed light to be mechanical waves which requires a medium called ether to propagate. Through it. What about the properties of this ether medium? Since it was found that the objects can pass easily through this ether medium, it does not offer any resistance to the motion of objects, so its inertia is very negligibly small. And since this light travels through it with a very large speed, at that time the velocity of light was thought to be at infinity, that means its elasticity must be very large, infinitely very large. So, it was, since matter can easily pass unresisted through it, so it has negligible inertia. The velocity of light being understood to be infinitely large required its elastic property to be infinitely large. So, Huygen's web theory was based on geometrical construction. It assumed there must be a medium called ether which is present everywhere, and this ether medium must possess negligible inertia and infinite elasticity so that light can travel with infinite speed and it does not offer resistance to the motion of objects. This was the salient features of Huygen's web theory. Now let us see Huygen's principle. Huygen's method was purely on geometrical basis, and Huygen's principle, according to it, all the points lying on the wavefront acts as a secondary source. This is very important point, secondary source. These secondary sources emanate wavelets with same frequency and velocity which the original source emanate. The position of the new wavefront is given by the envelope means outer boundary, envelope of these wavelets, So, once I know the position of a wavefront, then we can create the position of the new wavefront by some geometrical modifications. Let us see how. This is my source, and at some time, suppose AB is the wavefront. This is the primary wavefront, and according to Huygen, all the point lying, I call it P1 point, I call this P2 point, and I call this P3 point. So, all the points, there are infinite points here, act as secondary sources and wavelets emanate from it. So, wavelets emanate from this. So, these are the wavelets emanate from it. Suppose this is at t is equal to 0, and I want to know at t time the wavelets from here has grown to a radius of Ct. This radius is r equal to Ct. So, these are the wavelets, they have the same frequency and the same velocity which this wave is, and the position of the new wavefront is given by the envelope. Envelope is the outer boundary. So, this is the outer boundary, this is B dash and A dash is the outer boundary. You can see that there is one more outer boundary possible. We will call it inner boundary, not outer boundary. This is A double dash and B double dash. So the envelope of all these wavelets is A dash, B dash, since these are spheres. So this is also a spherical surface on these spheres, and this A dash, B double dash is also a back wave. Huygen explained that the amplitude of these wavelets is more in forward direction and 0 in backward direction. So only A dash, B dash is present. That means if at t is equal to 0, AB is the wavefront, then at t further time t, the wavefront has moved a further distance A dash, B dash. He further said that this back wave is absent because the amplitude of waves in forward direction is more, and as you go it is less, and in backward direction it is 0. So this is how he explains the absence of back wave. However, this explanation was not satisfactory. Anyway, in advanced wave theory, it was explained by Fresnel why these back waves are absent. Now suppose my wavefront at any time is a planar wavefront. This is AB as the planar wavefronts, and there are many points which act as secondary sources here. So they emanate wavelets. Suppose this has emanated, so this distance r, these are spherical wavelets, is equal to c into t time. The outer boundary of this is again a plane surface. So this is a plane wavefront. So after t time the plane wavefront further moves, and this is the direction in which the ray propagates and the wavefront propagates like this. So thus Huygen was able to explain with the help of geometrical constructions how a wave will propagate in time. So essential part of its principle, its theory was that all the points lying on this wavefront acts as a secondary source. They emanate wavelets which are in same frequency and they have the same speed, and the outer boundary of these wavelets gives the envelope of these wavelets give the next position of the wavefront, and the direction in which the wavelets will have more amplitude is forward, and in backward direction it will have 0 amplitude. This was Huygen's explanation, which was further modified by Fresnel. Let us see how Fresnel modified. Now we call this modification of Huygen's Fresnel principle. So Fresnel modified Huygen's principle by saying that, now Fresnel modified Huygen's principle by saying that the wavelets interfere to give maximum and minimum. That is, the phenomenon of interference was added. These wavelets interfere. So with these modifications, Huygen's Fresnel's theory could explain why back wave is absent, why it is propagating forward like that. So essential part is that wavelets interfere. This is the addition of Fresnel. So now the combined theory will be called Huygen's Fresnel theory, according to which all the points on the primary wavefront act as secondary sources. They emanate wavelets and these wavelets interfere and the envelope interfere to form a new wavefront, that is the wavefront at the next time. This is Huygen's Fresnel's principle. Now let us see how Huygen's principle can explain the laws of reflection and the laws of refraction. So laws of refraction, laws of refraction in the light of Huygen's wave theory. Laws of refraction in the light of Huygen's wave theory. So suppose this is a surface AB which separates two media, one with refractive index N1 and another with refractive index N2 greater than N1. So suppose this is a incident wavefront. This is the incident wavefront. AB is the incident wavefront. AB is, so let it be Mn. AB is the incident wavefront. So this is wavefront and these are the rays. So you see these rays are always perpendicular to the wavefront. This is incident wavefront. Now all the points A, B, you can take C point, further you can take D point. There are many points here. All the points are in phase. Now the velocity in this medium is V1, the velocity in this medium is V2, V2 is somewhat less than V1, we know. Now when first in this wavefront A reaches this surface, so when B reaches this point E, what happens? The wavefront from here, a wavefront will grow, a spherical wavefront will grow and this will grow to a radius like this. Suppose it takes tau time, so this distance is V1 tau. So in tau time this will grow to a radius R equal to V2 into tau time. It will also, this will also reach here, but it will take somewhat lesser time, so the wavefront from here will grow to a somewhat lesser radius. It will also come here before B reaches E, the wavefront at D reaches here and the wavelet from here will grow like this. Now we have so many points and so many wavefronts will be there. So the position of the wavefront will be given by the envelope that is a tangent plane to this. Tangent plane to this AE, let us call it F. So in this way the wavefront, the ray goes like this and FE becomes the refracted transmitted wavefront. We can define angle I and angle R. So you see here, if the velocity of light is here reduced, in this medium velocity of light is less. So when B reaches E, then and A reaches F, that means this distance will be slightly less than this. This distance will be lesser than this. As a result, we see that the ray bends towards the normal. Thus, whenever a light travels from one medium to another in such a way that in this second medium the velocity of light is lesser, then the ray will bend towards the normal. We can see its, suppose N1 is medium, N2 is another medium, and let us suppose that the velocity of light in the first medium is more. So what will happen? This is my wavefront. I am showing only, this is my wavefront. This is my wavefront. Now AB is my wavefront. So when A will first reach the surface. So when B reaches here, this is V1 tau. The radius of this will be greater than this. So what will happen, if you draw the tangent, it will be here, and the wavefront, this will be the wavefront, and the ray will go like this. So this is I and this is R. So the ray will move away from the normal. That means how the ray will bend will depend on the velocity of light in both the medium. Now let us prove mathematically the Snell's law. So here we won't take CD, we will draw a simple schematic diagram to study the laws of refraction with the help of Huygen's wave theory. Suppose Mn is the surface which separates two media. It has a refractive index N1 and it has a refractive N2 greater than N1. I have here assumed two rays, and this is the wavefront AB. So if I draw a normal, this angle becomes I, and when B reaches C, you see this distance is, velocity of light in this medium is V1, and suppose it takes tau time to reach from B to C, the wavefront here has grown to a small radius, this lesser than this. If I draw the tangent to it, then a CD is the refracted wavefront. CD becomes the refracted wavefront. So now this is the normal here, and this is R. If this is R, this is 90 minus R, so this is 90 degree. So this is R. This is R. This is I. This is 90 minus I, so this becomes I. So let us see these two triangles. So in triangle ABC, this is 90 degree. The ray is always perpendicular to the wavefront. Sine of I is V1 tau by AC. And in triangle ADC, we have sine of R. Sine of R is AD, that is V2 tau. This is the velocity in medium this, and in the tau time it will move V2 distance. So this is V2 tau by AC. Now sin I by sin R, sin I by sin R gives V1 tau by AC into V2 tau by AC. AC cancels, tau cancels, V1 by V2. Velocity of light in this medium is given by, velocity of light in this medium is given by C by N1, and velocity of light in the second medium is given by C by N2, that is N2 by N1. Further we can write it as N1 sin I is N2 sin R, or we can write simply as mu is equal to sin I by sin R, or N1 sin I is equal to N2 sin R, which is Snell's law. Thus, Huygen's wave theory could easily prove laws of refraction. This was the justification of law of refraction using Huygen's wave theory. You see the elegancy of the proof. Now let us see how law of reflection can be studied under Huygen's wave theory. Huygen, let us first see that this is a ray and another ray. So this is my AB is the incident wavefront, and this is my plane mirror Mn. Mn is the plane mirror and AB is the incident wavefront. Now this is the normal I am drawing, this is I. So what will happen when first A reaches here, B is still here, A and B are in phase, they are on the wavefront. When B reaches C, then it takes some time, tau, that is equal to this distance becomes C tau. Tau is the time taken from B to reach C and C is the wave speed. So C tau, in that time the wavelet from A has grown to a radius of C tau. So if I want to know the new reflected wavefront, then we will draw a tangent from this C to here. So this is the CD becomes the refracted wavefront. This is the refracted ray and CD is the refracted wavefront. So here let us concentrate on these two triangles. This is A, this is D, this is C, this is 90 degree, this is the wavefront. This is AD is the radius of the spherical wavefront, that will be also equal to C tau, and that another triangle ACB, this is equal to C tau. AC is common in these two triangles. This is 90 degree, this is 90 degree. This side is same to this. So these two triangles, triangle ADC is congruent to triangle CBA. Now you see this angle is I and this is the reflected wave. So this is R. So this is I. So we will have this 90 minus I. So this is I. This is R. So this is 90 minus R. So this is R. So this angle is R and we have this angle as, this angle as I and DCA as R. So now since these two triangles are congruent, this is BAC. So these two triangles are congruent. So now this angle DCA, so angle DCA becomes equal to angle DCA becomes angle to BAC. Now DCA is equal to R and this is equal to I. Thus this is what law of reflection. Thus Huygen's wave theory could easily and elegantly explain the law of reflection.